Hey everyone, my name is Alon Hafri, and I'm a postdoc at Johns Hopkins. And today I'll be discussing my work on the relationship between visual and linguistic symmetry that I think sheds light on the rich and structured nature of the language-cognition interface. To start off, take a look at these images. It's clear that they have something in common: symmetry, which has captivated not only artists, architects, and biologists, but also vision scientists up to the present day. But symmetry goes far beyond the visual and sensory world. It's also a foundational notion in scientific and logical reasoning. Take a look at this. There's a fundamental logical relationship between these statements. In particular, if we know that 1 is true, we get 2 and 3 for free. A is similar to B, and B is similar to A. This is representative of logical symmetry, and this property puts symmetry on par with other logical elements like negation and quantification. What's more, symmetry is threaded throughout the vocabulary of natural language, in almost every part of speech. For example, nouns, adjectives, verbs, and prepositions. So not surprisingly, symmetry has been of interest not only to vision scientists, but also linguists and psycholinguists. Now both fields talk about notions of symmetry, but this raises a question. What is the nature of symmetry representation in the mind? Is it just a coincidence? Two separate notions, different fields that use the same word? I think not. Consider that symmetry can be characterized at a general level as invariance under transformation. Take a look here at this left-right reflective symmetry. For all points in this figure, there's a corresponding point reflected across the axis, invariance to reflection, and it turns out that the visual system's exquisitely sensitive to such reflective symmetry. In logic as well, it can be characterized this way: invariance in meaning after inversion of arguments. A relation R is symmetrical if and only if, for all xy, if Rxy holds, then Ryx does too. And many predicates, like marry, refer to such relations. Thus, if John marries Bill, it entails that Bill marries John, but contrast that with a non-symmetrical like adopt. If John adopts Bill, it does not entail that Bill adopts John. Now I'll point out that symmetry is distinct from collectivity. Many predicates can refer to collective situations, so John and Bill marry entails both that John is getting married and Bill is getting married. Likewise, John and Bill drown entails both that John drowns and Bill drowns. But symmetry goes beyond collectivity. In the intransitive, it entails a reciprocal or mutual situation. So John and Bill marry entails that they marry each other. Contrast that with a non-symmetrical like drown. John and Bill drown does not entail that they drown each other. Now, although symmetry can be characterized as invariance under transformation in both of these domains, vision and language, does the mind treat symmetry in these domains as related? After all, these are very different cognitive systems operating over very different kinds of units. So here we ask the question, does a correspondence exist in the mind between representations of symmetry in vision and language, and under what conditions? We think yes, which may perhaps be surprising to some of you, but it highlights a view of perception that I'm interested in more broadly. In particular, that it traffics not only in low-level properties like the locations, shapes, or colors of the cars in this image, but also higher-level relational properties like the symmetry of this collision. Now, I'll say more about this perspective at the end, but if this is right, then it raises the intriguing possibility that perception may generate representations in a format that language may also engage with. If so, then we may find that symmetry has a surprising influence on judgments of how a visual stimulus and a linguistic form relate. And not just at a surface level, like the word being a good label for that particular scene, but even when the label and stimulus share little else in common apart from the property of symmetry. If we find such a correspondence, it has the potential to reveal something meaningful about how different cognitive systems, vision and language, interface with one another. To ask this question about correspondence, we utilize a cross-modal matching paradigm. Participants viewed simple visual events, symmetrical collision, or a non-symmetrical launch. On each trial, they saw one of these, and then they were instructed to choose between two English predicates, one symmetrical, one non-symmetrical, that best matched what they saw. Crucially, the predicates were not semantically related to the visual stimulus in any direct way, apart from the property of symmetry. But the logic is, if there's a correspondence between visual and linguistic symmetry in the mind, then we expect people to match symmetrical predicates with symmetrical visual stimuli. So marry would be chosen here because it matches the symmetry of the collision. Now let's try it ourselves. Watch each event and then decide which phrase is the best fit, 1 or 2, and type your responses in the chat window, if there is one. Here was a non-symmetrical launching event, so we expected people to choose the word inferior, the non-symmetrical predicate. Here's another. This was a symmetrical collision, so we expected people to choose negotiate, the symmetrical predicate. To see whether symmetry has an effect on judgments of relatedness, we generated a whole set of minimal pairs of predicates, symmetrical and non-symmetrical. So we'd select a symmetrical predicate like marry. It had to meet the linguistic criterion that the intransitive entails a reciprocal meaning. Then we selected a foil that was similar in many ways, semantically and otherwise, apart from symmetry. So a close match for marry would be adopt. And crucially, the foil did not obey the linguistic criterion. And we did this for a range of predicate pairs, concrete to abstract. Notice here that symmetry is not marked morphologically in English, so properties of the word forms are not sufficient to act as a cue. Nevertheless, our hypothesis is that observers will match symmetrical predicates to symmetrical events. And here are the results of our study. On the x-axis is each type of event. On the y-axis is how often a symmetrical predicate was chosen for that event type. Higher up means more symmetrical predicate choices, lower means more non-symmetrical predicate choices. And we found that for symmetrical visual events, observers more often selected the English predicate with a symmetrical meaning than for non-symmetrical launching events. In other words, yes, symmetry across domains was matched together in the minds of our participants. And I'll note this effect was remarkably robust. Almost every participant and pair of predicates showed this effect. Now we're suggesting this correspondence is at an abstract level of symmetry, but many symmetrical events just look visually symmetric, like collide, tango, and box. Are we just observing a match between what these situations look like and the visual stimuli? So we asked whether the matching effect was driven only by the concrete symmetrical predicates. Here, I'll rearrange the plot to depict a general visual linguistic match on the y-axis. Higher up means participants showed more of a cross-domain match for a given predicate pair. On the x-axis is concreteness, more concrete to the right. If our effects were driven merely by the concrete symmetricals, we'd expect a positive relationship here. More concrete, the greater the cross-domain match. But instead, we see the effect for both concrete and abstract predicates alike. In fact, some of the more abstract predicates show the strongest effects, like identical and equal. So it's not merely concrete symmetricals driving our effect. We think this correspondence is at an abstract level. This study shows that individuals have access to the formal property of symmetry of predicates, they're sensitive to visual cues to symmetry, and the commonality between these is intuitive, even for predicates that do not refer to concrete concepts at all. So yes, a correspondence exists in the mind between representations of symmetry in vision and in language. Next, I'll discuss several further studies showing a bit more about the structure of the representations. First, we wanted to investigate the generalities. In language, symmetry is a property of relations broadly. It holds not just for events, but also states. We asked whether the generality carries over to the visual domain. Would we observe the cross-domain correspondence not only for dynamic events, but also configurations of static objects? To ask this question, we ran the same study as before, but with one change. We used static figures, symmetrical and non-symmetrical. Are static visual stimuli sufficient to elicit the correspondence? The answer appears to be yes. We again found a matching effect. People chose symmetrical predicates more often for the symmetrical visual stimulus. This suggests that the generalities of symmetry that it holds over dynamic events and states carries over to this cross-domain correspondence. So we can ask about not just the generalities of symmetry in these domains, but also the constraints. If this matching is really happening where language and vision interface with the conceptual system, then the correspondence should respect the units where that interfacing happens. What are those units for vision? Now, although lower-level vision operates over features such as edges and contours, high-level visual processes operate over discrete units, visual objects. And we hypothesize that it is high-level vision, not low-level vision, that interfaces with the conceptual system. How can we test this? Well, let me bring in another image, a single static figure. Now, although there is symmetry here between the edges of the contours, this kind of visual symmetry may not be represented as a property of a binary visual relation in high-level vision, but rather as a property of this single object. If this is on the right track, then we predict the matching effect to be stronger for the image with two objects in a symmetrical configuration, rather than when it's the very same contour but with just one object, as on the right here. And we tested just that prediction. In fact, in the previous study with static images, we manipulated not only symmetry, but whether there were two objects in the image or just one. Here again, I'll rearrange the plot to depict a general visual linguistic match on the y-axis by just placing the non-symmetrical choices on top. Again, higher up means participants showed more of a cross-domain match. Here's the data from the two-object condition, plotted in this new way, essentially a different score. And here it is for the one-object condition. Now, although there was still an effect, it was significantly weakened. So yes, decreasing the perceptual accessibility of the binary relation weakened the correspondence. We can conclude from this that it's not just any kind of visual symmetry that interfaces easily with the conceptual system, even the extremely salient symmetry of a single figure. Instead, the mapping appears to be happening for relational symmetry of the kind that high-level vision outputs. Now, I don't have time to go into this next result in detail, but in another study, we also found this correspondence when observers did a similar matching task, but with a different kind of visual stimulus. They were tasked with inferring the meanings of signs from American Sign Language, or ASL. Crucially, the ASL signs were never a direct translation of the English phrases presented on a trial. But sign languages, including ASL, can express abstract relations spatially, including relations with the property symmetry. And the matching results here were the same as before. Non-signers who were unfamiliar with sign languages chose the symmetrical predicates more often for the symmetrical ASL signs, despite the richness in the appearance of these signs. I'm happy to answer more about this in the Q&A, but in the interest of time, let's wrap up. Bringing it back to the beginning, the property of symmetry goes far beyond sensory experience, to social situations, and even to the abstractions pervasive in scientific reasoning. What is the nature of symmetry representation in the mind? Today we've explored one part of this puzzle by revealing that both language and vision are linked to a common, abstract representation of symmetry in the conceptual system. This mapping is quite general, holding whether visual stimuli are dynamic or static, or differ in other rich ways. And the mapping is also subject to some constraints. By comparing this effect for two discrete objects versus one, we found that the mapping is most obvious when the symmetry is a property of a binary relation rather than of a single entity in both vision and language. Now we think these findings may have implications for acquisition of symmetrical predicates. I'll give just one example. Take two words, hitting and colliding, that are very similar in meaning apart from symmetry. How is a child to infer that just one of them, collide, refers to a symmetrical concept? Children will likely use many sources of information to do so, such as syntactic distributional information, but perhaps in addition, precious visual moments or gems could make the hypothesis of a symmetrical meaning especially salient in certain concrete cases. If the parent utters the word collide in the presence of this collision event, this might allow the child to make the inferential leap required to assume symmetry holds for that predicate. We're actually addressing some of these questions in our ongoing work, which I'm happy to address in the Q&A. But more generally, taking a step back, what have we learned? One major takeaway is a bit about perception, that perceptual processing appears to afford not only low-level properties such as the locations, shapes, or colors of the cars in this image, but also generates representations of relations that are abstract and structured and are in a format that can readily interface with higher-level cognition. In fact, I've summarized this perspective and the evidence for it in a recent paper in Trends in Cognitive Sciences with Chaz Firestone, and I'm happy to discuss more in the question and answer period. But a second major takeaway is about the nature of the conceptual system, and how we as scientists may investigate it. Approaching concepts from both sides, vision and language, has the potential to home in on how different cognitive systems interface with the conceptual system, and to reveal some of its core elements. And our results today suggest that abstract relational symmetry is one of these elements. With that, I'd like to thank my collaborators John Truswell, Lila Gleitman, and Barbara Landau, as well as colleagues for invaluable feedback, the NSF for funding this research, and thanks to you for listening.